Hello everyone, welcome to Vigyan Bharat. In this video, I discuss the problem of the day for today, that is 14th of July 2022, and is based from real analysis. The topic which I have chosen is upper and lower bounds, which often comes into the picture when we study very introductory chapter real number system. So before moving ahead for the problem, there is some terminology which we should know in order to proceed for the problem. And the terminology is very simple. You have often heard of least upper bound for any non-empty subset. So let's try to read and understand this terminology, that we are given a non-empty subset A of the real number line R, and this subset is bounded above. Now by bounded above, I mean that there exists some real number, say capital M, such that every element x of my set is less than equal to capital M, or capital M is greater than equal to x for every x in A. Then such a set A is said to be bounded above. Now, in our case, we are given that this set is bounded above. Now, a real number alpha is said to be a least upper bound of A. That is, this alpha is said to be the least upper bound of A if the following two conditions hold. That is, the first condition is that alpha must be an upper bound, which means that alpha satisfies that property, that every alpha is greater than equal to x for every x in A. Now the second property is, if beta is an upper bound of A, then this should satisfy that beta is greater than equal to alpha. If such a alpha exists, then we say that alpha is the least of all the upper bounds for the non-empty subset A. Fine, so alpha is the least upper bound of A. Now I pose a exercise to you to define an analog for the greatest lower bound for some non-empty subset B of R, which is bounded below. You can easily define on the similar line. Just everything will reverse. So try to prove this analog. Very easy. Now there is some notation. LUB of A denotes the least upper bound of A, which I have already explained to you what it means. And GLB of A is the greatest will be the greatest lower bound of A. You can take some particular choice of A in order to better understand this. You can assume A to be the open interval 0 to 1, which is a subset of the real line. So try to verify over it, find alpha and beta. You can do that. Now here is the problem for today. This you need to prove. So let's try to read the problem, that given, now it's in general, given any two non-empty subsets A and B of real number line R with this property that A is a subset of B. This property is given to us. Then we have to prove this inequality, that greatest lower bound of B will always be less than equal to greatest lower bound of A, will always be less than equal to least upper bound of A, and which will be less than equal to least upper bound of B. So this is the problem I want you to prove using the above terminology. So try to prove this problem, and we'll come with a detailed solution of it tomorrow, but try to prove it.